Hey there, everybody. It's Pete Yost for the Unbuild It podcast. But before we get into the podcast, I want to let you know about two outstanding events that are coming up in our industry. They are both BS and Beer symposiums. The first one's going to be in Denver, Colorado, September 12th and 13th at the Blue Moon Brewing Company. And then the next one is in Charlotte, North Carolina, October 10th and 11th at the Lenny Boy Brewing Company. If you haven't been to these events, they're so much fun and so stocked with information because it's people that are at the top of the industry sharing what they've learned in the field. And it's what's better than combining that with really good beer. These are outgrowth events from the BS and Beer series and content on Green Building Advisor, but this is where you get to, do it in person. It's absolutely outstanding. So do you have to remember all these details, which I'm going to repeat in a second? No, of course not, because you can go to bsandbeerkc.org and get all this information. But once again, if you're lucky enough to be in Denver, Colorado, September 12th and 13th at the Blue Moon Brewing Company, that's the first event. The second event, Charlotte, North Carolina, October 10th and 11th, Lenny Boy Brewing Company. That's a mouthful. But anyway, if you go to bsandbeerkc.org, all the information for any upcoming events is there for the BS&B series. Sure hope you can join the Unbuild It podcast there. And now, on to the podcast.
Hey, Unbuild It podcast. Steve Basic here with Jake Bruin, and we got one hell of a treat for you today. We have the one and only Ross Trethewey with us.
Hey, guys.
I thought you were going to billboard it as Peter's not here, and that's the treat.
Well, that is a treat, too.
Plan B.
We dropped Pete. But yeah, we're out here at the 25th year of Building Science Summer Camp out in Massachusetts with Building Science Corporation, and we're going to grab a bunch of select people from summer camp and try and have a conversation with them. But yeah, we're opening it up with Ross. And Ross, can you, in a few sentences, just tell us a little bit about yourself?
Yeah, I'm Ross Trethewey. I'm a mechanical engineer. Been doing this for, 18 years now. Started my own firm back in 2010. It's called TE2 Engineering. We do basically mechanical design, but as well as electrical, plumbing, and fire protection. We're really focused on high performance buildings, and we're trying to be more focused on the residential part of the building. So we're 70% residential, about 30% commercial, which makes us kind of unique because most of the consulting engineers that we see and talk to are more the other way, right? Either 100% commercial or 70-30 commercial residential. Also on the television show, This Old House. So it's a nice kind of pleasant distraction is the way I think about it, where it kind of gets me out of the office and we get to get to see some cool stuff and talk about some cool, technologies. And I host a thing called Future House. That's the segment on there. But that's me.
Cool. Very cool. Well, we have a few questions. So this is actually kind of a little mix in here, huh, Jake, where we have a couple write-in questions.
Yep.
And they're obviously mechanical questions, although we do have one in there that has to deal with some pretty serious structural engineering that we'll throw to Ross later.
Hope not.
No, just kidding. We have some good mechanical questions from our viewers. So all of you out there listening, if you got questions, email them into
questions@unbuilditpodcast.com. That is where the overwhelming majority of these have come from. There are a couple from Building Right. Is it building-right.com?
Yeah,
it's Peter's website.
When Peter's not here, I try not to think about him.
Yeah, well, don't give us a website you have to spell.
Yeah.
Right?
Yeah, or have to think that much about.
Says the person
Right,
who owns
with a
company that's not
W.
spelled correctly.
Yeah.
So.
Basically, well, I'm going to let you ask Ross the first question that
You have
Peter
the
just
list over
the
there.
one that Peter just let us into before leaving the room.
I forgot.
No.
I wasn't paying attention when he actually said it. So
We're going to break the fourth wall, and Peter had to leave early. And so we're recording this, and Peter was like, Jake, I need you to ask Ross this question while I was setting up all of the recording equipment. So I'm going to let Ross ask himself the question just because I think it's funny at this point.
Well, he was yelling at me. He said, hey, can ERVs self-balance was the question. And so the answer to that question is it depends on the ERV. Most ERVs, residential ERVs, cannot self-balance. So when you install an ERV system, what you're supposed to do is hook up a manometer to measure the static pressure across the core in both directions. One's the exhaust air stream, right? Exhausting air from the building. The other one's fresh air outdoor air, bringing that air into the building. And those are often at different duct runs in terms of lengths, number of fittings. And so the static pressure on each of those two airstreams are different. And so the newest ERVs have the ability to have ECM motors, which are electric commutated motors, and those are variable speed. So it just allows the speed motor to be able to be adjusted to whatever CFM you're trying to hit for how much airflow you want in both directions. And some of them have the ability to self-balance, meaning in the sense that you can set it for 50 CFM, for example, in both airstreams, and it's going to try to spin the blower motor to move 50 CFM of air. And so it's doing a calculation based on static pressure and RPM of the motor to figure out how much CFM is actually moving. So as your filter starts to plug up, it will start to spin the motor faster to try to overcome that static, to try to move that 50 CFM. So that's the self-balancing part of these ERVs. A lot of them can't do that. A lot of them, you're setting a low speed and you're setting a high speed fan. And we call them potentiometers. So they're like little screw adjustments where you can throttle the fan down or throttle the fan up at a set low speed and a set high speed.
And so if you're wondering if your ERV will self-balance, is the first place to do is look at the box and see if there's any ports for a manometer to connect to it.
Well, the best ones will have ports already built in regardless of whether it's self-balancing or not. Yep. They should
but the
have
ECM motors are a requirement
the
for
ECM
balancing.
That's
Self-balancing.
right.
Yeah.
That's right. Yeah. To take a regular PSE motor, which is the old school motors, those are designed to set at one speed. It's just on or off at that point. And that's how they used to be designed. But that was the problem that you would hear is that the ERV would bang on, it would bang off. It was really loud. The airflow was always running at its maximum speed. There was no ability to adjust. So now that's all changed with ECM motors. Most manufacturers have just standardized on that. And they're so much more efficient from a wattage standpoint.
Yeah, I was just going to ask that. Does the ECM motor make them more energy efficient?
100%. Yeah. So some of these ECM motors, when they're running at low speed, you could be at 20 watts of power for the unit. High speed might be at 60, 70 watts. So we're talking about less than a 100-watt light bulb to run the ventilation system for a lot of these houses. And so that's really the ECM motor is the game changer there.
I think one of the things that you said in your answer that a lot of people have a hard time wrapping their brains around is you have two arms of ductwork and they go in different shapes and different lengths.
Yep.
And everybody looks at them and goes, well, but they're the same size.
Right. I got an 8-inch round going there. I got an 8-inch round going there. So, they should be the same. It's like, well, no, that 8-inch round's going 25 feet with 3 elbows and going that way. And this one's going 80 feet the other way with 12 elbows. Of course, they're going to have very different static pressures, very, very different amounts. So you have to put more fan horsepower into the one that has a longer run. I think it almost like it's 2 airstreams, 2 air handlers. Just happen to be in the same box with 2 fan motors that you can't really see.
Well, and the other part of that equation too is even the less expensive, the more cost effective. We always say more cost effective.
Better way to say it, yeah.
Even the more cost effective ERVs, you're even dealing with different filters on each side. So you might have like that scrub brush. Filter
a
on
MERV
one
4
side
on one side and a MERV 13 on the other side as an example.
And so everything is different about them.
That's right.
So,
yep. And some have, motorized dampers in them to prevent frost buildup in them. So they have a bypass. So there's like even the airstreams within the physical units aren't always equal in terms of the resistance across it. Yep.
Okay. Question number 2. I will let you in again. Steve doesn't know what question I'm about to read. Neither does Ross.
It's a mystery.
I'm reading this, because it may or may not be an HVAC question, and B, because it actually mentions this old house.
I almost wish I had a drum for a drum roll.
It's not that good.
It's such a mystery.
Sorry,
It's a question.
Hi, my name is Quentin. I'm a painting and remodeling contractor. I love the show. I look forward to every episode. Thank you, Quentin. Not to date myself, but I remember getting hooked on this old house when it first came out.
Mm-hmm.
So he's older than me.
1978.
Because I wasn't alive. I've been in and around building pretty much my whole life. My dad's a drywall finisher and plaster man, along with other skills. He remembers when the first paint roller came out and the old painters of his day laughed and said it would never catch on.
Mm-hmm.
My question for you is, over the years, we've seen products and techniques come and go. Are there any products or materials from the past that you cringe thinking about? Also, is there anything from the past that you think was just trendy but changed your mind on? What do you see today as a keeper or will end up in the Museum of Regret? So I thought that was a good, like, we have a lot of experience around this
question.
table going, dang, I wish we wouldn't have done that. I, until very recently, thought that gas-powered pass-load guns were a total mistake because we bought all new pass-load guns in the late 90s thinking we won't have to have hoses again. And we ended up having 6 guns for 3 guys because we always had 2 or 3 in the shop. Yeah. And they were a nightmare. And I remember my dad explaining to me that we had wasted like thousands of dollars on them. I do believe that I have come around on them now because I used one recently and I was like, oh, it works. Mm-hmm. They just didn't work when they first came out and we bought in immediately.
Right. I would say the ones, so a technology that comes to mind or product that comes to mind that's a dinosaur, and I'm glad to see it be a dinosaur now, is evaporative pad humidifiers. So a lot of times they call it bypass humidifiers, but think of it as
I don't know what it is. Yeah.
So if you have think of a sponge that's porous that allows air to flow through it. And then you have the equivalent of a 1/4-inch water line that basically applies water across the sponge. So you're basically creating a wet sponge and the air goes across that and picks up moisture. So it's evaporative humidification. They were used because they were cheap, they were cost effective. They put them in, different residential HVAC systems kind of across the board. And what we found is that when you actually pull that cover off and you take a look at it, especially because they usually don't get serviced, is that thing is just a moldy, nasty, just gross device.
You're just creating a filter that's soaking wet that stays wet.
Do they have the nickname Swamp Cooler?
Swamp Cooler.
Yeah. Okay. Yeah. Now I know what you're talking about.
Yeah. So I don't like to. But you're right. Swamp Cooler.
Swamp Cooler is what everybody knows them as. As soon as he started explaining it, I was like, okay.
So the technical one is this evaporative pad humidifier. But yeah. So those have always been awful. And I'm glad to see those pretty much go away.
That's because you live in the Northeast, not the South. I think they still exist in quite a few markets.
No, they still exist. I still walk in houses and I'm like, oh my goodness, that thing's
They're comfortable to sit in front of though.
Yeah. Half of them don't even work and just putting water on the floor and stuff like that. But yeah, so that one definitely is dinosaur for sure. When I first started, the air conditioning systems were all like SEER 13 or lower. Some of them were even SEER 11. And so the air conditioning systems were so good at dehumidifying that you didn't actually need mechanical dehumidification. And the buildings were so leaky so that the cooling costs were always there. And so one of the things I didn't think that would actually become a thing in the Northeast has been mechanical dehumidifiers. So I think I've gone completely the other way, partly because our buildings are getting better, building enclosures are getting better. The heat pumps and air conditioning units are getting more efficient. So they're actually getting less and less of the latent load, meaning they're doing less dehumidification. And we are now pumping in more ventilation air to buildings. So I think the confluence of all those factors mean that mechanical dehumidifiers, I think, are here to stay. And I never thought I'd be speccing them in Maine or in Massachusetts, but they're almost a part of every project.
So from a building science 101 standpoint, like backing up on what you just said, just for the base level knowledge, we used to have equipments that required longer run times and they had greater loads because we had leaky buildings, meaning the coils stayed cold for longer periods of time and caused dehumidification for longer periods of time.
Right.
And now we have equipment that doesn't run as long. The coil doesn't get as cold. So therefore we don't get as much condensation on the coil. And now we're ending up putting humidifiers in.
And to take it a step further, if I took an old low SEER AC piece of equipment, that system ran at probably a 60-40 split between sensible load and latent load. So meaning that if I had a 1 ton, or make it simple, a 2-ton air conditioning
system. And they were
drastically oversized to begin with.
Right.
And on top of that, you had let's say a 2-ton SEER 10, SEER 11 air conditioning unit. 60% of that 2-ton capacity went to drop the temperature of the room. 40% of it dropped the moisture in the room, the latent load in the room. So the hidden moisture is the latent load, and that's a part. But now if you look at a new piece of AC equipment, let's say a SEER 18, SEER 25, a lot of those sensible heat ratios are somewhere, 85%, 90%. So 90% of that same unit drops the temperature room. Only 10% actually drops the moisture in the room. And so manufacturers are now getting to a place where to make it more energy efficient on paper, they have to warm the coils up A warmer coil means less dehumidification. So the sensible heat ratio, the SHR, is the number one thing I'm looking at for what will this thing do for dehumidification. So if I look at a new piece of equipment, sensible heat ratio is going to be 0.85 all the way up to 0.98 in some cases, where the old stuff was all 0.6, 0.65, 0.7. So the ratios were 60-40 or 70-30 or something like that.
And
hopefully that made sense.
The folks in my father's generation look at that and go, "Oh, you're wasting so much money. Now you're putting in dehumidification." We're still ahead of the curve on it. Like, we're still in a better point. We have to.
Right.
It's important to note.
And if that building enclosure gets better, right, the load, everything just came down on that. We do have to add that dehumidification, but the actual dehumidification load is far less than what it was with the old piece of equipment. So we're still winning the game at the end of the day.
What about you? What's the thing that you thought was going to catch on that didn't, or the thing that caught on that you were surprised by?
Yeah. Well, I guess I'm not surprised, but I don't know. I'm going to make a different conversation out of it. But like offsite construction, just, I've been at this for 30 years, and like we're still talking about the same
5 years from
thing, right? Like the same thing somebody is saying this last year that I heard him talk about is something I heard when I started working at Building Science Corporation in the late 90s. And people were arguing, like, hey, we should do this and that. And it's just like, keeps getting regurgitated, but not really effectively put together. And I say this because I just spent last week, I went out to an offsite. We're doing an offsite build. And I was actually quite impressed with how they operate out there. And there are some things that they can do or that they're doing there that you wouldn't see on the job site. And the fact that, they're in upstate New York, so they can build every day of the year, whether it's raining, freezing cold, whatever the case is. And the other thing is that they coordinate. They're building basically the floor frame and the wall framing and the roof trusses. So they're in charge of the full coordination of the engineering of it. So we were in there and they were actually making our floor assembly parts. And so they're putting in blocking in the different floor assemblies where there's a column up above that's going to carry a girder truss. So, when you're out in the field, it's like I walk around and I see guys and they're like, "Oh yeah, we'll put that blocking in later. Or we'll put those joist hangers in later." And later just becomes a challenge a lot of times. Or it just becomes forgotten. And so it's picking up, but it's not taking off like a lot of people think or want. Or and I mean, I could also say the same for energy efficiency. I mean, the three of us operate in a world of where we want to design really good buildings, but for every time I have a conversation of why we should do it, there's 10 people out there telling me I'm wasting money. It's a dumb thing. Why would you want to do that? We can build out here and wherever for $110 a square foot. And they're calling me the criminal. I'm like, no, buddy, you're the criminal. If you're building a house for $110 a square foot, I don't care where you are in the country, you're the criminal.
Yeah. It's the conversation you and I had the other day about if they hear our number first, the other guy sounds like he's cutting corners. But if they hear the other guy's number first, we sound like we're ripping people off.
Yeah, you guys are gouging. Yeah.
We're looking for a boat payment.
Expensive.
Yeah.
But the one thing that is happening that I think that's slowly coming around, and I'm saying this because Ross is sitting in front of me, but even as much as like 8-10 years ago, there were no real mechanical engineers for the residential part. Right. And now they're slowly coming on. And I mean, I did a house. It was a zero energy house probably like 8 years ago, and designed it all up. We sent it out. And the mechanical contractor came back with like 60,000 BTU system or something for heating. The homeowner's like, "Steve, we went through all this. You're supposed to design an energy efficient house. Look at this number. The guy wants to put in 5 mini splits. The house is 1,500 square feet. And I told him, I said, his name was Steve. I said, "Steve, it's wrong. Trust me, it's wrong."
Right.
And we sent it to somebody that I thoroughly trusted, and it came back and it was like 16.4. Right. Because there's so many assumptions. They don't understand the European windows. They don't understand air tightness, and I don't quite understand their, the mechanism to get there, but the guy that told me, he says the guy that did it right, he said, those guys, they have 3 choices for air tightness, like leaky, good, and great.
Mhm.
And even great isn't as good as passive house numbers.
It's still 3.
Right. Yeah. And, if you're taking a commercial engineer and having him design a residential mechanical system, forget about it, right? Like what works in the commercial sector does not work in the residential sector. It's like apples and oranges, different products, different design philosophies, different everything, right? Like, we talk about interior zones and perimeter zones in heating and cooling systems commercially. We don't have that like when we have in our living room or something like that in a house. The rooms aren't big enough. We don't have the ventilation loads like we have in a commercial building. So to take a commercial, engineer or, system and try to apply it to a house is it's just fail from the start. You're going to get a 60,000 BTU design when it only needs a 16,000 BTU design, right?
Yeah. But what's interesting is clients have become more in tune with their surroundings, I would say, in the last 20 years in building a house. And commercial, it's funny because I don't think commercial has really caught up on that. Like if you're working in an office building and you're in your office and it's a little chilly, you just put on a sweater or you wear a long sleeve shirt in July or whatever the case is. If you just built a house for somebody, they're going to come out and say, hey, Steve or Jake or Ross, you guys designed this house, built it, and designed the system. We're freezing upstairs in this room, or we can never get this room warm in the wintertime.
Right.
And it's crazy how much they've become in tune with it that it's almost required that we have to do this stuff.
You're absolutely right. I feel like a lot of clients, at least in the high-end residential space, they've built their beautiful dream house and they actually go to live in it and it doesn't perform the way that they're expecting that home to perform at. And so there's a disconnect. And a lot of times it was, design build. There's nothing wrong with that. But a lot of the HVAC technicians are great technicians. They're not great designers. So they don't have always the skill set to be able to design and apply the right systems for the right project. And so one of the things that we've tried to do to change that is put together a client expectation sheet. So we're trying to figure out what are the pet peeves of this homeowner that drives them nuts from a past house.
Or what is the reason I will never get a call back?
Right.
That's the lens that I see everything through.
Yeah. Because, comfort, for example, is subjective, And so, everyone's understanding of what that might be in their home is different, and budgets are different, et cetera, et cetera. So if we have at least rate from the client what they are expecting, what their goals and expectations are, that gives us a much better chance of getting the HVAC design right, for example, on a project.
So when I don't know if you know this, Ross, I built a house for my family from 2018 to 2020. Yeah. That Steve was the designer on.
And then you started framing.
I'm so happy my wife does not listen to this podcast because she would agree with you. She would mail you things to say thank you. But when we sent it to our mechanical guy, he came back with what you and I both agreed was a ridiculous number for BTUs. I think 3 times what we ended up at.
Yeah.
And then we sent it to a mechanical engineer that's close to my market, but not exactly in my market. And his specialty is residential. Yep. And when he came back, I said, I was looking at the manual J. We're going to be below 1 ACH 50 and we have triple glazed windows and you don't have those things in there. And he kind of just said, it's not going to affect the number. Ooh. And I was like, I'm fairly certain it does. It's a big part. It's 15% of the envelope.
The air tightness of those windows. And, going back to that one house I just told you, we went from 64 down to 17. And the guy who I thought did it right, he spec'd 2 systems. One of the systems never even comes on.
Right.
So even him with his knowledge was probably twice of where we needed to be.
And we know there's some conservative factors in the manual J as well on top of that. Yep.
So then we went to my mechanical guy, you and I did, and basically said, this is what we want to do. Trust us. And my mechanical guy was kind of just like, it's your house. It's going to be your problem.
I'll do it. I'll put it in for you, Jake.
He's like, but I don't want to know. I don't want to hear anything.
Don't give me a call back. Yeah.
And we moved in and we're very comfortable. And the house has very low energy bills. The systems don't run all that often. And I made the mistake after we were there for about 6 months of buying a half dozen temperature and RH gauges that are $10 a piece. And immediately my wife is telling me the RH is above what you said it should be. And the temperature from this room to that room are this far apart.
Oof.
And I attempted to just get rid of the gauges because she was perfectly comfortable
before she had knowledge of what.
But then she found them and put them back around the house.
The worst thing we did was create thermostats with digital displays.
It is a nightmare.
Because now people will look at that and say, oh, it's not at the number I thought it would be. Are you comfortable? Yes or no? You know?
I catch myself looking at the thermostat still.
Turn it up a degree. Turn it down a degree.
Like a jerk when I do too.
I'm going to throw a certain somebody under the bus. Right. So there's a person that I talk with occasionally or give lectures with. Right.
Sometimes publicly.
Sometimes publicly.
Sometimes on a podcast.
And then some. Yeah. But anyways, so I have actually heard him up on stage talk about how, like, you know, 2 or 3 degrees, we really can't recognize.
It has to be more than 3 degrees.
Yeah, it has to be more than 3 degrees to recognize. And humidity we're even worse with. And then we'd get in my truck and leave the place. And he's over there going, oh my God. And he literally turns his control on his side 1 degree. And I was like, weren't you the guy that just told me that you can't recognize a 3 degree difference? And somehow you're recognizing a 1 degree difference here in the truck. But anyways, it's one of those things with knowledge. That's why I don't subscribe to, like, when people say, oh, we need dashboards, we need to see all of this stuff. No, we don't. Because the minute we see it, our brain starts churning that information and we go from comfortable to, maybe not comfortable anymore.
Right.
And it's not that we're not comfortable. It's just that I understand that I shouldn't be comfortable.
Right.
Well, and I took, I walked around my house with a much more accurate thermometer and did a bunch of readings and realized that the thermostats don't give accurate numbers. After my HVAC convinced me to spend
you should have consulted with me, because I would have said, just tell your wife, listen, those are the $10 models. If you want the exact reading so you can truly understand comfort, I can go get the $150 ones, but I didn't think you wanted me to spend $1,000 on monitoring equipment.
There you go. I like that spin. I like that spin.
Substantially longer than me.
I used to live in Europe, and when I was over in Germany, there is no digital thermostats. They literally have a slider, red to blue.
Just I still got the round Honeywell.
Oh, the gold knob. Yep. The Honeywell TD7. I know.
It works. I said it 26 years ago. I haven't moved it.
But if you're like, all right, I need a little colder, a little hotter, just turn it, spin it, you know?
I like that. I think that's what I need to install at my house. Does it need to go colder or does it need to go warmer? Also, the garbage thermostats. I won't throw the manufacturer under the bus. Displays a feels like temperature.
Mm-hmm.
Which then that adds a whole other level of confusion. Feels like what?
You might think it's 72 in here, but it feels like 68.
Because if we're talking about feelings, I tell you that I have different feelings than my wife most of the time. So Ross, what do you have coming that we should know about?
Coming up, I don't know. It's a good question.
We didn't tell you we're going to ask you to plug anything.
Yeah.
I mean, still on this old house.
Yeah.
Future house.
Yep. Doing Future House, doing this whole house. We got the TOH Lexington project going on right now.
Tell us a little bit about Future House. So, like, I get it, Future House, but what do you talk about?
Yeah. So Future House is one of the segments of Ask This Old House. And the whole idea is, what's a technology or a product that's really in its infancy that we think may be one day part of the house? So it's a nice way to get creative with it and say, hey, I have no idea if this new solar panel that's see-through, transparent, that can be made into a window, for example, I don't know if that's something that might be part of the future or not. But hey, you know what? It's a cool MIT invention. Let's go talk about it. Let's go show the American audience about this new technology. So it's kind of a nice way to get creative with it and start to try to get the crystal ball out and try to predict what technologies might be deployed in the future. So
you should just go to the Bau show, because then we get to see where we're going to be in about 10 years.
The what show?
The Bau show, the German building show.
Yeah.
We get to understand where we'll be in about 10 years.
Yeah. Yeah, they are. I mean, when I lived over there, it was eye-opening, interning with a German company over there. And I was working in the R&D lab. And I was like, some of the stuff that they're working on, this was what, 20 years ago. It was literally, heat pumps that we had never heard about, absorption style heat pumps, They were working on different code generation systems. They were working on all the stuff. I'm like, this is some amazing engineering, and it's not even on the radar screen here in the States,
Or like that, when I just went this past spring, and they had a ventilation system that was packed within like a 10-inch diameter in about a 10-inch tube.
Mm-hmm.
And it was a full ventilation system. And I asked the guy, I was like, when is this going to come? He goes, yeah, we don't service America with this. We don't sell it there.
Yeah.
It's only for
There's so many manufacturers that do that, It is changing though. It is changing. A part of that is the high cost of energy here that's now starting to take shape. It used to be that, places in Europe would pay 35 cents a kilowatt hour for electricity, and we were paying 8 and 7. It's like, well, those products and those technologies don't pencil out when cost of energy is cheap. But now the cost of energy is coming up. We're paying a lot more for a gallon of gas. We're paying a lot more for electricity, et cetera, et cetera. So because of all that, now some of those products are starting to come over. And it's starting to make more financial sense. Because if it doesn't make financial sense, no manufacturer is going to, spend the money to market it and get a whole rep team going and all that kind of stuff. So, but yeah, it's cool stuff.
Yeah, solar panels are even a hard sell in my market when we pay 11 cents a kilowatt hour.
It's crazy. Yeah, it's really the delta between that and gas or propane or whatever you're comparing it to. It's the delta that matters the most. But other things that are coming up, we've got the building symposiums.
Yeah,
in Charlotte, in Denver. Yeah,
in Denver, looking forward to Charlotte.
Yeah,
Denver this September 10th and 11th, and Charlotte. I don't know, Charlotte. Yeah, stay tuned.
bsandbeerkc.org, and you can figure out when they are.
That's right.
But
that's right.
I know Denver's early September and like mid to mid October is Charlotte.
Those are good if you'd like to see Steve and Ross be my opening act.
They're great.
Actually, you go
great.
before me.
Technically, I opened and closed last time, so I was my own opening act even. Okay, well, Ross, where is the best place to find you besides this old house?
TE2 Engineering or Instagram, I think are good spots. And occasionally on Twitter. I guess we should call that now X. We call that X now?
I don't know.
But yeah, whatever it is.
I'm going to pretend to be old and still call it Twitter for now.
But yeah.
I was ever on Twitter.
Yeah, at Ross Trett. Yeah, at Ross Trett over there. And TE2engineering.com.
Okay. Ross, thank you for joining us today. It's a pleasure. Oh, yeah. You're pointing at one more thing that Peter shoved in your face.
That's right.
Don't forget to talk
he handed
about
me this widget. Yeah. So I got to mention this. So I put a couple of these in my house. I did have to try it out. So Panasonic partnered up with Swidget. Swidget is a smart widget. And it's basically, think of light switches and outlets that can now become smarter. So I use their devices to do demand control ventilation for my ERV in my house. So for example, this widget can be ordered with different sensors in it. So you can sense temperature, relative humidity. You can sense VOCs, particulate matter. And so if it senses a high level of particulate, a high level of VOCs, it can turn the ERV into boost mode automatically. I also have it tied into my bathroom switches. So basically, if the relative humidity rises in the bathroom, my kids are showering, for example, it will kick the ERV into boost mode and starts basically exhausting all that moisture out of the house. So I'm a big fan. I've had it probably in my house for a year and a half, 2 years. And, I always like to test it first. My wife hates me because I'm always testing out all these new devices, but it's working really, really well and really, really happy with it so far. So
you could put one in the backsplash that's PM 2.5 or VOCs, and you could put one for humidity in the bathroom like you've done.
That's right. Yeah. So you can now take regular bath fans and make them smarter. So if you had, 40 people coming over your house, for example, for a big party, you could have all your bath fans kick on if the CO2 level rose in the house, for example. They've got a bunch of cool different things for bath fans, for ERVs, but also tying it in for other things. They have motion sensors, so you can have occupancy sensors if you wanted to. You can, for example, if I wanted to turn a light on, if I walk into a closet, you can have that. So there's different use cases like that. And so it's just taking the traditional, fan switches and light switches and outlets and making them a lot smarter.
You were going to be Pete's new favorite person because you remembered his question and then you remembered to talk about the one thing that he was interested to get your opinion on. So
I was just
anything to keep Peter happy.
Like a month and a half or 2 months ago, Peter and I were at a conference, and we walked up to the Panasonic booth, and this woman comes over, and I go, I'm just thinking to myself, right?
I'm warning you.
Like, lady, don't. Oh, can I help you? And Peter just rattles off stuff. And she literally just stared at him. And she said, just 1 second. She went away and like some other guy came over and said, hey, I'm the tech rep for Panasonic here. And you had a few questions. And then Peter and him, it was like a love fest with these two. And I was just sitting there going, all right, Pete, we got to go. But they were just.
Steve was sending me pictures of Peter opening their display ERV and pointing at stuff, going, I can't get him to leave the booth.
Like,
come on, Pete. Come on.
Yeah, they're like dissecting it. The guy's got this little screwdriver out, and he's taking it apart, and they're holding the different pieces. And I was like, oh my God.
Yeah, but that's the reason that he can answer my questions when I ask him.
Oh, yeah.
Yeah, we love this.
So I'm okay with it.
I love Peter. I love Peter. When I have that question that I have no idea, I just call Peter.
I feel like us engineers, we're very simple people. We like things the way they work. We're curious about how they work. And once we get into something that we like, it's a full deep dive. We want to know every little thing about it.
I agree.
Which is good and bad.
Mr. Host, you want to take us out?
Yeah. So there you have it, folks. The Ross Trethewey from this old house and engineer extraordinaire. So, yeah. And listen, if you guys are out in the Denver or Charlotte or within 2,000 miles of either one, I suggest you travel because I just saw Ross present down in Connecticut when we did it. And it is worth going just to see Ross present. His presentation was awesome.
Thank you.
So, Unbuilded Podcast, you heard it here. Send us emails where again?
Questions at unbuilditpodcast.com.
Yeah, we love having them. And if you got questions, you could be like Quentin and not use your real name and just come up with, Quentin and say you're a painter when you're really the mechanical engineer or the mechanical guy on the job. And just say, yeah, I'm Quentin the painter. So, we can use it as a joke. From now on, everybody could just be Quentin the painter.
Thanks, Q.
With a question.
Yeah.
And
appreciate the question.
But yeah, seriously, on a serious note, email us. These questions are great. If you're thinking of it, chances are, 2 or 3 of the other, 200,000 plus listeners are probably thinking the same thing. So ask away and we'll do our best to hit them.
And I'll tell you that I brought 14 pages worth of questions with me to Building Science Summer Camp. And our goal this week is to force somebody to not leave the conference and go straight over to Joe and Betsy's for a drink and sit with us like Ross just very graciously did and answer a couple questions. So you're going to get some of the best building science minds in the country answering the questions, unlike normally when it's just you and Peter and I.
Awesome.
I have a This Old House related story. Do you know Tom Silva lives about a mile from me?
I didn't know he lived.
We lived in the same town for like 26 years, and I've never met him.
Really?
That was your story?
Yeah.
I thought it was going to be one of your dad jokes.
No, I wasn't prepared enough.
Okay.
Well, if you want to meet him, we can make that happen.
Yeah, that would be awesome.
Yep.
Okay. Till next time. Have a good day.
Cool. Thanks, guys.